Hi everybody, welcome back to this course on internet technologies. I'm Vardan and today we'll be studying about SHTTP and HTTPS. Secure HTTP or SHTTP was developed in mid 1990s as an early attempt to bring encryption and privacy to web communications. Unlike HTTPS, which secures an entire session, SHTTP focused on encrypting individual HTTP messages, both requests and responses, independently of one another. So every time a message is sent, the client first selects the encryption parameters such as the algorithm and key size and then encrypts just that particular message. It's essentially a per message security model, not a session based one, which makes it very different from how modern HTTPS works. Once the client sends an HTTP encrypted request, the server uses the agreed upon parameters to decrypt and respond. But here's the catch: each message must go through a fresh negotiation process. There's no persistent session like we have in HTTPS, so it's more computationally intensive. Also, forward secrecy is not supported, which means if someone were to compromise the private key later, they could decrypt old messages also. Over time, these limitations, along with the complexity of managing message specific encryption, led to the decline of HTTP. Today, it's practically obsolete and has been entirely replaced by HTTPS. Now, HTTPS or HTTP Secure is what we use today to secure nearly all web traffic. It's essentially HTTP running over TLS, which provides encryption, integrity, and authentication. Unlike SHTTP, HTTPS encrypts the entire session, not just the messages, meaning all your HTTP headers, form data, cookies, and even browsing activities are protected. One of its most important features is forward secrecy. That means even if the private key is compromised in the future, past encrypted sessions cannot be decrypted because every session uses a unique ephemeral key. Additionally, HTTPS relies on X509 certificates. These are signed by a trusted certificate authority to authenticate the server you're talking to. Let's break down how HTTPS actually works. Your browser initiates a connection to the server, typically on port 443, which is the standard for HTTPS. Then the TLS handshake begins. The client says hello and includes a list of supported TLS versions, cipher suites, and a random number. The server responds with its own hello, chooses the best cipher suite, and sends its X509 certificate for identity verification. Optionally, the server might send additional key exchange information. The client then verifies the certificate, and if all checks out, it shares a session key, typically using a secure key exchange method like the Diffie-Hellman. From this point onward, everything is encrypted: HTTP headers, payloads, cookies, even the URLs that you're using post request on. The connection can also remain open, meaning multiple HTTP requests and responses can reuse the same secure TLS session. The result is a secure channel that ensures confidentiality, data integrity, and mutual authentication.